Once soil is gone, farming is over. And when farming is over, food follows. In parts of India, farmers stopped this with a plant. Not dams, not chemicals. A grass. Planted in lines across hillsides, it does not wash away. Its roots grow deeper than most trees. During monsoons, it slows floods. During droughts, it traps water underground. Over time, it rebuilds the soil itself. For more than 200 years, this single plant protected water, food, and land at once. Then modern agriculture removed it, not because it failed, but because it made too many problems disappear. This is vetiver. And this is the story of the plant that solved 3 crises at once and was ignored anyway. Before the age of inputs, gardens were not collections of crops. They were living systems. Water, soil, and food were not managed separately. They were woven together through the placement of specific plants in specific locations. Farmers in tropical Asia understood something modern agriculture forgot. The health of what you harvest depends on what you plant around it. Hedgerows were not decorations. They were infrastructure. Certain grasses were placed along slopes to slow runoff. Certain trees shaded root zones to preserve moisture. Certain plants were grown not for their fruit, but for what they made possible beneath the surface. These were not primitive methods. They were biological engineering. Every element served a function. The landscape itself was the tool. Gardens designed this way did not deplete the soil. They built it. They did not waste water. They guided it. They did not just produce food. They protected the conditions that made food possible. But somewhere along the way, we stopped designing systems. We started assembling parts. And in that shift, one specific plant vanished from landscapes almost entirely. In the river valleys of South India, there is a grass that has been holding soil in place for centuries. Farmers did not grow it to eat. They grew it to protect everything else. Its name comes from Tamil, vetiver. It means the root that is dug up. But its true power was never in being harvested. It was in being left alone. Vetiver was a choice to leave nature to do its work. Planted in dense rows along contours and field edges, vetiver formed living barriers. During monsoon floods, it slowed the rush of water. During dry seasons, it kept moisture from escaping. It asked for nothing. No irrigation, no fertilizer, no replanting. Once established, it stayed. It required almost no inputs from the farmer. By the 1980s, the World Bank began studying what Indian farmers already knew. They called it vetiver grass technology. Researchers confirmed erosion reductions of up to 90% on slopes where it was planted. Runoff decreased by 70%. The grass was not a crop. It was a structural element of the landscape. But what made it so effective was not the leaves above ground. It was what no one could see beneath the surface. Most grasses spread sideways. Their roots fan out just beneath the surface, competing for shallow moisture. Vetiver does the opposite. Its roots grow straight down. In the first year alone, they can reach depths of 2 to 4 meters. In mature stands, roots have been documented at 5 meters. This is not a root system. This is an underground wall. Unlike trees, which anchor deep but spread wide, vetiver roots form dense vertical columns. Packed together in a hedgerow, they create a living curtain beneath the soil. Scientists measured the tensile strength of these roots at 75 megapascals, roughly 1/6 the strength of mild steel. Researchers found vetiver roots increased soil shear strength by up to 45%. This is why vetiver does not wash away during floods. This is why it survives droughts that kill crops around it. The roots do not just hold soil. They interact with water in ways that rewrite what happens during a storm. They slow what moves fast. They store what would otherwise escape. What scientists discovered was not a gardening trick. It was a hydrological intervention hiding in plain sight. When rain hits bare soil, it runs. It gathers speed. It carves channels. It floods low ground and leaves high ground dry. Vetiver breaks that cycle at the source. Planted along contours, the dense hedge acts as a living dam. Water moving downhill hits the barrier and slows. As velocity drops, the water spreads laterally instead of rushing forward. This buys time. Time for the soil to absorb. Time for infiltration instead of runoff. Studies showed that vetiver hedgerows reduced surface runoff by as much as 70%. That water did not vanish. It entered the ground. It recharged aquifers. It stayed in the root zone where crops could access it weeks later. During extreme rainfall, vetiver hedges also trap sediment. The grass acts as a filter, catching soil particles before they wash into rivers. Over years, this builds natural terraces behind the hedge. The slope flattens itself. By guiding moisture deeper into the soil profile, vetiver changes the timing of water availability. Fields with vetiver hedges stay moist longer during dry spells, but slowing water was only the first effect. What it did to the soil changed the land permanently. Erosion does not just remove dirt, it removes fertility. Topsoil contains the organic matter, the microbes, and the nutrients that make crops grow. When topsoil washes away, what remains is dead ground. Vetiver reverses this process. By trapping sediment uphill of every hedge, it captures the richest fraction of moving soil. Over time, these deposits accumulate into bands of deep, fertile earth. Researchers documented natural terraces on slopes where vetiver had been planted for just a few years. The rebuilding goes deeper. Vetiver roots, when they die, leave channels through the soil. These channels improve aeration and water movement. They become pathways for new roots and soil organisms. The grass also protects microbial life. By shielding the ground from direct sun and reducing temperature swings, vetiver hedges create conditions where bacteria and fungi thrive. Studies confirmed that vetiver systems increase organic carbon over time. They improve structure. They raise fertility without added inputs. The grass does not just prevent loss, it actively rebuilds what industrial farming destroyed. Because it is perennial, it does this work year after year, without replanting, without tilling. Vetiver is not a food crop. You cannot eat its leaves. You cannot harvest its roots for calories. But every farm that grows vetiver grows more food because of it. By controlling water, vetiver extends moisture available to nearby crops. By stopping erosion, it preserves the soil those crops depend on. By creating windbreaks, it shelters young plants. Farmers in Asia discovered that planting vetiver hedges between rows reduced water stress and improved yields even during erratic monsoons. In Africa, trials showed that fields bordered by vetiver lost far less topsoil than unprotected plots. The benefits multiply. Vetiver hedges trap runoff that would carry fertilizer into streams. They reduce pest pressure by hosting beneficial insects that prey on crop destroyers. In traditional systems, vetiver was also used as mulch. Cut and spread between rows, the leaves suppress weeds and release nutrients as they decompose. The roots were sometimes harvested for oil used in medicine, but these were secondary uses. The primary function was always structural. The grass held the farm together, so everything else could thrive. Food security does not begin with seeds. It begins with systems.
Something changed in the 20th century. Farms stopped being ecosystems. They became production lines. Water was separated from soil. Soil was separated from food. Each problem got its own solution. Irrigation systems delivered water through pipes, ignoring what the land could hold on its own. Fertilizers replaced organic matter that erosion carried away. Pesticides replaced the balance that hedgerows maintained. What had been a single living system became a collection of purchased inputs. Inputs require sellers. The new model demanded products, pumps, chemicals, engineered seeds, machines. Every function a plant once performed for free became a market opportunity. Erosion control became concrete barriers. Water retention became plastic-lined ponds. Soil fertility became bags of nitrogen from factories. This was not accidental. It was an economic restructuring of the landscape. When agriculture becomes an industry, permanence becomes a problem. A crop that solves multiple issues at once, that never needs replacing, that spreads without purchase, has no place in a system built on annual transactions. Vetiver did not disappear because it stopped working. It disappeared because it worked in ways that could not be monetized. Vetiver does not fit modern agricultural economics. It cannot be patented. It does not require annual seed purchases. It does not respond to proprietary fertilizers. Once planted, it stays. This is its greatest strength. It is also why industry ignored it. When the World Bank promoted vetiver grass technology in the 1980s, the science was clear. Trials across India, Thailand, and Africa showed erosion reductions of 95%. Water retention improved. Soil health recovered. But adoption stalled. Extension services funded by seed and chemical companies had no incentive to promote a free, self-perpetuating solution. Research institutions chased grant money tied to patentable innovations. Vetiver could not be sold at scale. Its propagation is vegetative, not through seed. You dig up a clump, divide the roots, and replant. Neighbors share slips over fences. No transaction, no middleman, no profit margin. In a system that measures progress by sales volume, a plant that multiplies freely is a dead end. So the journals called it impractical. The supply chains ignored it. The grass that could have anchored farms through climate chaos was left at the margins, waiting. And now climate is forcing the world to look again. Climate is changing the math. Droughts are longer. Floods are more severe. Soil is washing away faster than policies can respond. The old solutions are failing. Concrete crumbles. Irrigation wells run dry. Fertilizers stop working in dead dirt. Farmers are returning to what survived. In Thailand, vetiver is being planted along highways to stabilize slopes that engineering could not hold. In China, it anchors mine reclamation sites too toxic for other plants. In Australia, it filters agricultural runoff before it poisons coastal reefs. Studies confirm what the data always showed. Vetiver hedges reduce erosion by up to 90%. They cut runoff by 70%. They increase soil shear strength by 45%. They survive temperatures from -14 to 55 degrees Celsius. They grow in rainfall zones from 300 to 6,000 millimeters per year. Regenerative farming movements are planting vetiver as a core component of landscape restoration. Indigenous farmers who never stopped using it are being consulted as experts. The grass that industry ignored is becoming essential infrastructure for a planet under stress. Not because it is new, because it was always right. Vetiver was never a product. It was a relationship between land and the people who tended it. It asked for nothing and gave everything. It held slopes together during monsoons. It kept water in the ground during droughts. It rebuilt what storms tried to destroy. All of this quietly, without packaging, without branding, without annual fees. That is why it was erased. In an economy that turns every function into a commodity, a plant that cannot be commodified is invisible. Vetiver did not fail the market. It refused to participate. The knowledge was never lost. Farmers in India still grow it along their fields. Communities in Southeast Asia still share root divisions over fences. The grass keeps working wherever it is planted, but forgetting has a cost. The soil we lost could have been held. The floods we suffered could have been slowed. The water that disappeared could have stayed. All of it, waiting beneath a grass we chose not to see. This is not a story about rediscovery. It is about recognition.
The plant that solves water, food, and soil at once was always here. Some systems were designed to last.